TypeScript compiler and doing some cool stuff under it. So to start off, I'm using this open source project currently for a company that I started that is struggling, but we'll get there. It's called Sassify, and the basic idea is that you can wrap open source functionality in very focused TypeScript serverless functions and deploy them with our platform. And we auto-generate like a fully functional SaaS website that anyone can sign up and pay for your API. So I'm really passionate about open source. I wish I could work on it more, and it's a problem that you can't get paid for it. So I'm trying to make it easier for open source authors to get paid. So back to functional TypeScript. What the hell is this thing? So you take a basic TypeScript function like this, and what we're going to do is we're going to process it and figure out the specific types of the inputs and the outputs, and then convert it into an HTTP endpoint that you can call via GET or POST with any standard JSON, and we're going to do type checking on it when you call it. And the complex part of this is going to be, okay, well, how do we take in any valid TypeScript and figure out, what JSON schema is going to look like for that. So let's scroll down and just take a look at an example. So this would be an output from the program on a hello world. So we see that the parameters, this function takes in one parameter. It's the name of the parameter is name. It has a default value of world, and its that type is string. We won't allow any extra parameters. And this format right here, what this is called is JSON schema, and it's just a very standardized and well-supported spec for.
Can you blow it up?
Yeah.
For people in the back.
A little bigger. Is that better?
Yeah.
Okay. And then same thing on the return value. This is a standard JSON schema describing a return value. Now for Hello World, this isn't that complex, but it really gets powerful when you can wrap any open source project that has TypeScript definitions or add a small little TypeScript wrapper and auto-generate all the documentation and have type checked endpoints. So let's talk a little bit about serverless. So serverless is there chalk? Yeah. So serverless, first off, is a computing paradigm that is starting to take off. There's a lot of hype around it, and there's this thing I like to talk about. It's called the Gartner hype cycle, where for a lot of technologies, you tend to go like this. Where you get a lot of excitement about a technology in the beginning, and then people realize it's not really going to solve everything, and so it kind of drops off. But over time, as it matures, and I think I'd be curious actually to hear whether or not TypeScript will follow this path. But serverless functions are kind of right here. There's a lot of hype. You may have heard of them before. AWS, Google Cloud. There's a lot of offerings for how to write and deploy these TypeScript these serverless functions. And the real power in serverless is that it allows you to just focus on the core functionality without focusing on any of the infrastructure. And the way that serverless functions work is that you only pay based on usage. So if no one's calling your function, you're not going to pay anything. And at the same time, the providers allow it to scale up. They say infinitely, but within reason. So if you make 0 calls per second, or if you're making a million calls per second, you're going to pay per call, which is really nice because traditionally you need to have a bunch of really heavyweight servers or scale-out servers, and if people aren't calling them, then you're paying for it. So serverless is, as I said, just kind of a newer technology paradigm that is coming with a lot of hype, but there is some reasons for the hype, and I'm going to kind of talk a little bit about how to use TypeScript with serverless. So first off, what does a serverless function look like? This is how you would write the hello world function on, on AWS at the top, on Microsoft Azure, on Google Cloud, and then this is how you write it with functional TypeScript. So the first thing you'll notice as a main difference with this is that in the TypeScript version, this is just 100% normal TypeScript function. You don't have to deal with HTTP encoding or decoding. You don't have to deal with parameter validation. and it's just kind of more natural. If you wanted to take this functionality and move it somewhere that wasn't serverless or to a different provider or something, there's zero vendor lock-in with this version, right? It's just the core functionality, which is pretty powerful. So this might look like some other RPC stuff to you. I mean, there's like SOAP and gRPC and a lot of really good RPC mechanisms for making remote calls, and in particular type-safe calls that can be kind of optimized. And this is just essentially, you can think of it as just a small alternative where the main advantage is you only need to know and understand TypeScript. So everyone in this room, has some level of familiarity with TypeScript, and this is really powerful just to make it so so easy to get started with these things. So let's actually jump in and look at an example. Let's see which example I want to use. Let's look at an example over here. So I'm going to talk a little bit about the source code and how it's implemented, just because it's really interesting to me, and I'm sure that some of you guys will find it interesting. So these are just a bunch of fixtures, normal TypeScript functions. You can import other modules. You can.
Can you make it a little bigger?
Yeah, for sure.
Can someone in the back tell us if it's reasonable?
And switch it to light mode.
Light mode? I don't know how to do that.
Apple Shift P.
What?
Apple Shift P. Theme. Color theme.
Okay.
Just pick a light mode.
There we go.
Oh, wow.
Ooh, nice.
I do this for a
I was
living.
going with the spooky. This is like half a Halloween costume, by the way. So, okay, so we have a bunch of these example functions over here. I think the one that it's set up to target right now is at the very bottom of this guy. We're going to look at a medium complexity example, and what we're going to do is I'm going to first show you the output and kind of what it's doing, but we're going to look at the source code that we're going to run this guy on. Medium.ts is just, it's using enum, it's using the interface, it has some default values, using some async stuff, so it's just a non-trivial example for instance. And we're going to run the FPS parser on this. We're going to go ahead and run it and hope that it works, because live coding is always okay. So I'm going to pause right here. We got to a place where essentially what we've done now, and this is really hacky. So we've created a dot version of that same file, but we've appended the input params and the output params as interfaces to that. Now, it's a little bit hacky because we want, if this file actually has imports and touches other files, we want to make sure it's in the same place. But then what we're going to do is we're going to use another open source project. Let's go back to the parser, where we're actually going to take those two interfaces that we've created and extract them with a project called TypeScript to JSON schema. So this is another amazing open source project. If we end up talking at any point, you'll hear me talk about open source a lot. It just converts between TypeScript types, so you give it a TypeScript interface, and will try to return the best approximation of a JSON schema version of that type. And JSON schema is powerful mainly because it's just interoperable with a lot of other stuff. So that's the gist of kind of how it works, and I'm just gonna keep going, and we'll take a look at the output of what that just generated. So we'll see that this function takes three params. Nala, by the way, is the name of my cat. And then let's see, for each of these properties, we have a reference, so either an inline reference, this is just standard JSON schema to its type, if it has a default, or in this case, it's a more complex type, so we have a reference to a definition that's over here. And so this was, Nala was a interface, I believe. Go back up. So this is representing this interface. And if we go back down to the console, we can see that it's properly getting all of the subtypes and the recursive types and everything in between it. I've actually been fairly surprised at how this simple approach has worked on very, very complex types. So there's like a one project called Sharp, which is an image processing library that has an enum of like 40 different objects that you can take in sub-objects and things, and just because TypeScript is so standardized, it just works, which is pretty cool. So let's actually take a look at what one of these would look like in practice. So this is an example project. Again, the company that I'm working on, the product I'm working on is called Sassify. And this is a project that takes an open source module called figlet.js by this guy, Pator JK. If you know him, tell him thanks. He is going to get 80% of any revenue that this SaaS API makes, assuming that he responds. So the idea is that you can wrap something like that in a TypeScript function. We're going to take a quick look at what that TypeScript function looks like. A little bigger. So we're going to import the original open source module, and the only real challenging part is figuring out how to standardize and make this TypeScript wrapper and make those types explicit. And then we leave the actual implementation, calling it down below to the underlying open source project. So what this ends up looking like, some examples, you can again do either Git requests. If we make this Git request here, we'll end up with this string boom. We can say something like Anders, and I can show you that it's actually live. We can change the font to be teachable. And it's going to give us an error because it actually knows that that's not a valid value in the enum. So this is very powerful. And then let's take a look actually at so this there's a hosted version of this API that was this is all auto generated. And then we can take a look at the docs. And this is where like the power of this this schema comes into play. So these docs were all auto generated based on a spec known as OpenAPI. Which shares the same data format as JSON schema. Again, like JSON schema is just so standard that being able to play between TypeScript and JSON schema has a lot of really cool possibilities, like auto-generating this type of documentation. So if we can look at this example in Node.js or Perl. We can look at it. This is the list of all the fonts that library supports. And then we can take a look at like what it looks like in Python or Perl, and then we can actually copy this and go to the console, paste it in, and see it live. So the power here, a couple things that I just really want to reiterate is one, like TypeScript is an amazing base technology just to build this type of project off of. The compiler, the open source community around it, it would have been so much harder to build this without that great tooling. And then two, like I am very passionate about trying to make open source more sustainable. So if any of you have worked on open source software or are interested in working on it, but the fact that you're kind of working on things for free, or people are asking you to maintain stuff, and you kind of get sick of it after a while. If you can just wrap it in a TypeScript wrapper and throw up for free a hosted version of it, one, you could potentially make some money off of it. Two, you open up that library to a much larger audience. So even though open source is powerful, it tends to be very isolated amongst different programming communities. So if you have a project in JavaScript, and you offer a hosted version, now anyone from any programming language, as long as they can make an API call, can invoke your function. So let's see, was there anything else I really wanted to show? Oh, one more thing I want to mention, just on the underlying side is we're using pretty heavily this library called tsmorph. And this is, again, another open source library that is built on top of the TypeScript compiler. It's essentially just like a much simpler API for navigating a TypeScript AST that looks more like how you would expect to use it. The TypeScript compiler is really powerful, and sometimes you need to go, this is like a layer on top of that. But it's also very verbose, and if you want to do anything in terms of navigating things, it can just be a lot of boilerplate. And this allows you to say, like, find the child node that is the return value type, or it really kind of like DOM traversal to do those type of things. So this is an awesome project. I feel like we could have an entire talk just about this at some point, but I guess before I go in and either go into implementation stuff or anything, I just want to pause and ask if there are any questions about serverless, about kind of this generating of TypeScript to JSON schema stuff, or what we're trying to do with Satisfy. There's so much energy in this room right now.
So I mean, just to clarify.
Yeah.
So does Satisfy essentially make JavaScript libraries into web APIs?
Yeah, exactly. So let's
and it works with only JavaScript libraries?
So we support Python, JavaScript, and TypeScript. And the idea is that it should work with any JavaScript, TypeScript project. You can have a package of JSON, you can import whatever external modules. Now there are some rough edges right now around if you have like native dependencies. You can't stick them in a Docker file or anything. So, but if it's just using like pretty standard open source JavaScript modules or TypeScript modules, it's really actually pretty quick to get going. Yeah.
I wrote this super elite Bitcoin miner in JavaScript, TypeScript, and/or Python.
Yeah.
What can stop me from abusing your service?
That's a good question. Let's talk more afterwards, because abuse is something that like we certainly are monitoring it, and this is a real company. Like it's we are going to be trying to make money, and we need to address some of these concerns. But like monitoring and also there's another one that's very common where if I want to publish someone else's work and create a paid version of that, how do you prevent that, right? And in the aggregate, I truly feel like just the spirit of the open source community, that's not going to happen as much as you would think. But certainly if there are cases of abuse, we'll address them as they come up. Yeah?
I assume you're writing a wrapper around the functions that you're going to get into to abstract away the inconsistency between the providers. And
Yeah.
you probably have to do type validation.
Yep.
How does that affect my cost per invocation?
So,
Or like if you
yeah.
talk about like, let's say I have 2 million, like if I have 10 invocations, doesn't
Yeah.
matter, but
So first off, like there's two sides of this. There's you as a maker who's like creating this project, a project on here, and then there's like the end developer who would be calling this. And it's a valid concern that like there is a little extra amount of schema validation for inputs and outputs. You can bypass that, then you lose a lot of the niceties around auto generating documentation and stuff. Performance is something for the V1 of this product, we're not super focused on. We built this on top of Zeit now, and they're built on top of AWS Lambda. So if you're familiar with the phrase, it's turtles all the way down. At some point, we'll focus more on optimization, and that'll be something we'll want to follow up on. Yeah.
Is the schema available from that endpoint so that I can like pull down the schema and validate client side and then before making my request?
Yes. So let's take a quick look at what that would look like. So this, for instance, is an example text to ASCII art. If you go up to the top, the schema is available for all of these, and it's a standard open API schema that you can. It has very good cross-language and platform support for working with these schemas. So if you wanted to for instance, validate your parameters client side, you could do that. Right now, there's no way to bypass validating it server side as well.
Oh yeah, no, of course.
Yeah,
Yeah.
for sure.
And then maybe also, what about TypeScript definition if I wanted to like look at an API endpoint and get like compile time support?
Yeah,
I guess
so
I'm
first,
thinking
first
like
off,
kind of a rest, kind of a
Yeah.
rest kind of thing. It's like
I mean, first off, like we're young, right? Like
Yeah.
this is pretty early on. But the idea is that these all link back to the source on GitHub. You add a GitHub badge, and then once you can view the source, and also like, so for instance, let me show you one more example here. We could go look at a Puppeteer example. So Puppeteer is a project by Chrome, by Google, that allows you to run headless Chrome, which is really nice for workflow automation. And if we take a look at the implementation, we're actually importing the real types from @type/Puppeteer and using them in our definitions of what we're doing. So in general, we're going to try to be as one-to-one with the actual types from the underlying open source module, along with this side of things. But to answer your question, like we're not auto-generating a TypeScript module yet. There's this one cool project that I just want to show a quick shout out to. This was a Microsoft, or an offshoot from Microsoft guys. They allow you to say put in a TypeScript file, and I'm not involved with this by any way, so it's not like I'm plugging things. But so they allow you to plug in a TypeScript file and get out a JSON schema definition, and they're using the same open source library under the hood. The difference is that they allow you to do a whole bunch of different languages, like Python or C++. So at some point we do have plans to kind of offer auto-generated type-safe clients in different languages. But product development, you kind of need to go one thing at a time. So.
Can you generate TypeScript from the JSON schema?
Yeah.
Yeah, so that seems like that would be a good.
So this actually is going through an intermediate step. You can see it's not exactly one-to-one on the left and the right. It's going through the JSON schema underneath the hood right now. But let's look at a JSON schema type here and generate some TypeScript. So this is kind of the conversion. This is a really interesting project made by these two guys out of Microsoft, and the whole. I guess the main thing I want to emphasize here is that like TypeScript and the community around it is just so vibrant that there's a lot of tooling like this that allows you to interact with other languages, and that becomes very powerful in terms of building things on top of each other. Yeah.
Are you familiar with the NJSON schema? We use that at work, and it goes in that direction. NJSON schema is a .NET project.
I am not familiar. Is it related to JSON schema?
Yeah, we write the JSON schema.
Yeah.
And then from the JSON schema, it generates TypeScript and C#.
Okay.
So it's pretty interesting.
So they might even be using this under the hood. And JSON schema, if you guys haven't heard of it, check it out. It's just very nicely done and very interoperable with a lot of different projects. I think that's it. Any other questions? So one last pitch just before I go. I'm basically would love to talk to anyone here who is interested in TypeScript, open source, or in trying to build a hosted version of some of your projects. The idea is you just create a TypeScript function, deploy it with Sassify, and then you earn the majority of any revenue that was to make. So if you want to earn passive income, or at least be able to play around with TypeScript stuff, it could be a cool outlet for that. All right, thank you.